Welcome to Simulation and Prototyping. This is the concluding tutorial for Grasshopper 2. We're building off of what we just did with this kind of big giant grape surface in the courtyard. We can delete everything that I can just put it on a different, I can move to a different layer and I can hide all of that. So let's copy our definition down and we will manipulate it. Maybe my computer's running a little slow. I'll see if disabling the solver in the other places. I know that we have them paused, but maybe if I disable it, it will help a little bit. Okay, so we have our last example here. Let's start the same way and let's create a surface. We could even probably start with a mesh, but it seems like it's much easier to draw corner to corner surface. And here's, because I changed everything to vertex before, I'm going to turn on endpoints. So I can select that. Now we've got a surface at the floor of the courtyard. Let's set this surface with our surface container. Everything else should be working with that. We have our mesh surface. So let's make a couple of changes this time. So we have our deconstruct mesh and our mesh edges. We're not going to use our mesh edges this time. And I do want to also deconstruct our B-rep. And the reason for this, we'll pull our surface into our B-rep. This will get us the 4 points at the corners. I think we were probably a little more sophisticated last time, but at least now we can see our workflow from our surface, which we can hide in Rhino. And let's see, this gets us, by deconstructing the B-rep, pulling the surface in, this gets us the 4 corner points in a parametric sense. So let's set those to be our anchor points. We can delete the anchor point that we had, and we can copy it and set that to be the target. And then what I want to do is internalize the data, which basically makes it no longer parametric, but allows us to manipulate those points. So we have those for the anchors. In this model, what I'd like to do is, rather than use the load, where we were loading all of the vertices last time, just as a way to mix this up, we'll go back to what we did earlier and we'll use our vertex loads from the mesh tool, from the goal meshes. Set this here, and then we just, all we have to do is pull in our mesh. That makes that easy enough. And let's set this to be vertex loads. I think this is going to be a minus number, so let's do / -10. It's easy enough to change. So we have, let's see, we can hide our B-rep, we can hide those points. Keep our target points on because we want to play with them later. Let's look at, so let's change our, swap out all of this stuff down here on the bottom for our line lengths. We can delete that. And let's put in edge lengths again from our mesh. just to show you a couple of different options and different formal responses to these things. So edge lengths, we'll put this here. We'll pull our mesh into there. And let's set a couple of things. So our length factor, do //1. We'll see how this works for the length factor. And for the strength, let's set this to be //. Let's start with 1,000. We'll see if that works for us. So we've got anchor points and target points. We've got a load on our surface, on our mesh, and we have edge lengths. So let's plug these into our merge. Let's enable this. We're not seeing anything because we have to preview our bouncy solver. Let's reset it. So we've got a minus length on there. And so it's draping down into the courtyard. So for our vertex loads, we can go from 10, let's change that number to be 2. Let's see how that looks. It should slowly emerge out of the surface. There we go. So that's looking good. The edge lengths, let's see what happens. If we change the length factor, again, these are the edges. Let's go to 0.5. We can see the surface kind of shrinks up in the middle. We're only holding the edges by 1 point. Let's change the 0.5 to 5. I want to say it's between 0 and 1. Let's see what happens when we give it a 5. It seems to not like that. I'm going to reset. Also seems to not like that. Let's try 2. And otherwise, we'll just go back to 1. Can reset again. So that's just allowing the length to get much longer. Let's see. Let's see if we change the strength from 1,000 to 100, and then we'll try 10,000. So 100 makes that even taller. Let's add another 2 zeros. Should bring it down. Not by a lot. So let's go back to the length factor and set that to be maybe 1.1. Just got deflated quite a bit. I'm going to hit reset. This is the strength. Maybe I'm going to change the strength back to 1,000 instead of 10,000. Now we move a little faster. All right, so we have a simple surface here. Let's do 2 more things. We added, and just because I want to get you used to doing this and knowing that we can do it in multiple ways, actually, let's do a couple things. I'm going to go to my target points. Let's just change the 2 front points. We can elevate them. Maybe to the top of the canopy on the front. This is nice, just being able to work interactively with these and kind of see the result. So let's add a couple more target points. Those were the points from the corners of the B-rep. I want to pull down one point over on the other side, but let's do this with an additional anchor. So we don't have to plug everything into here. So let's go to the main, to the anchor under goals and point. Let's add another anchor point. I'm just going to turn my solver, pause my solver for a minute while I do this. And let's plug in our anchor to our merge. So we have it. Now let's do what we did earlier. We will bake our mesh surface just temporarily. I can hide my bouncy solver. And let's set some points. We'll make a point container. We'll plug this into the point. Let's see, let's right click and let's set one point. We want this to default, or not default, we want this to snap to one of the starting condition vertices of the mesh. So we can select that and it's set. Copy this. Let's add a target point. And let's internalize these. Oh, they are internalized. Okay. Believe we can delete our mesh. We have that. And now let's just set our strength. Well, I guess the strength is set to 1,000 as a default. Let's preview our bouncy solver. Let's reset it. And let's unpause it. So now we have slightly different control. We have our 4 corner points, which are parametrically set by our mesh. Sorry, bad rotating right now. Turn the solver off, or pause the solver. And now we can see we have a point that we're pulling down. I want to pull down, let's see, edge lengths, load. Let's change the load from +2 and set it to be +1. This should drop the height. Can reset it. So the last thing that I want to show you how to do is to set a load with one force vector. And so this is something that's kind of more common if we see a kind of column or prop with something like this. So even 1 seems quite high. The edge lengths. And 0 will not do much for us. Again, my computer is not very happy. I think probably the stronger the load, the faster this goes. Maybe it has to do with the edge strength. We turn that down and see if this is any better. actually like the panels, being able to swap the numbers in for these things now. Okay, so now we have a much flatter surface. So the length factor I turned down, the strength I turned down. So maybe that's a little too much. Let's try 0.85. Sometimes the problem with sliders is that you have to end up changing the slider because you want to switch to a completely different number. All right, so I'm pretty happy with this. Let me just manipulate our last target point and even pull it down through the courtyard. We could trim that as we did before, but I just want to add one more element and show you how to add a kind of point load based on a vector. So this will be a load that we apply to the surface. And so we can do this with goals, point, and load. We've used this tool before when we applied a load to all of our vertexes. But let's use this load. The point that we're going to want to use is from a point container, and we'll use our same trick as baking our mesh surface. I'm going to pause the solver, hide the solver, and I just want to pick a point again as a vertex. See, I can plug our load into our merge. I want to pick a point that is a vertex on our mesh. Once we do that, we can delete that. This should be internalized. It is. And now with this load, what we want to do is for the force vector, we did this previously just using Z. What we can do this time around is draw a line. We can have this come in a different direction. And so in the front view, I'm just going to draw a vertical line, which we wouldn't need to do if we wanted just Z, but let me rotate that slightly. And rotate it slightly in both the front and the right view. So now we have a trajectory that we can add a force. So the force will be a unit vector. Plug that in. And actually, I don't want to plug that in. I want to do multiplication. So we have a little bit more control over it. We'll add the vector to the multiplication. We'll add the multiplication to the force vector. The vector will be defined by a curve container that we will set parametrically tied to that curve. We can multiply. And then this needs to be a pretty large number. Let's start with 10,000. We can go up from there. So we should have our point. Our point is set. That's all set. That should be working. Let's turn back on previewing our bouncy solver. Let's unpause it. And now you can see what's happening. So we can reset. Actually, so there was the line that we drew. And here's our point where it initiates. And here is our trajectory. So we can do a couple of things now. Maybe we can turn that down from 10,000 to maybe 7,500. It's not quite as tall now. Maybe I'm gonna try 5,000. And we can also manipulate that trajectory. And so even if we want to go back to the different views, can rotate it around. Maybe a little too much. From the right view, okay. So that gives you, I like that loading condition based on a trajectory that gives you a lot of control for manipulating the surface. So we can see the kind of stretches that are coming across that from pulling this down and pushing this up. And the last thing that we can do is our trick from before, is that we can split our B-rep. And let's just make a trim on the top. So I'll use a planar surface. Come up to there. Let's set this B-rep. Let's hide all of our other things. We can pause our simulation. We can hide that B-rep. And now we have a nice representation that is also a NURB surface. We could bake this. We could move any of our target points on the corners, but this is completely parametric in terms of the way that it's being manipulated and being resolved. So this allows us to end on what I think is a nice, solid example and gives you a number of different ways for manipulating the simulation, either by moving the target points, which are parametric, or adding additional forces to kind of poke or pull the surface in any number of directions. And the one that we just did with a trajectory, this can be positive or negative, which we can see here with the curve and the vector and the multiplication. It's positive 5,000, but we could also make that negative 5,000 if we wanted to push it the other way. So play around with these. For class, I'm looking for your hanging chain simulation, and then 3 variations of these. And we can talk a little bit about the representation techniques that are coming through the assignment. But as far as rhino and grasshopper is concerned, you now have your first foray into using a simulation tool, at least for form finding. I would say that you've been using simulation all along as you've been simulating light. And we will talk more about light and heat and structures going forward as we look at different types of simulations. So I hope this helps you. Please let me know if there's any questions. If you thought it was helpful, like the video on YouTube and subscribe to the channel. I hope to bring you more tutorials. And while many of these are specifically dedicated to assignments for the simulation and prototyping class, as I do things, I'm going to continue to add short tutorials on specific components or plugins or other things. And so keep an eye out for those. My hope is that anyone that's in the class will continue to use this tool going forward. And those updates and those short tutorials along the way might help with your workflow and help with the other things that you're working on. So thanks for watching, and I'll see you with the next tutorial. Thanks.